This video will cover the second page of notes on the topic of exponential functions. Here our job will be to talk about graphing transform exponential functions. So one of the things I want to remind us of is that an exponential function is in the form of y is equal to b, where b is the base and x is going to be our exponent. So a couple of things that we actually already know is that if we have a number on the outside, it actually moves it up and down. So we know that already from our other functions and transforming other functions. We also know that if it's in here with the x, either a plus or a minus h, it's going to cause it to move it left and right, depending on if it's positive or negative. And then the last thing that we also know is that if it has a multiplier, it will have a multiplier up here in front of the b. For the most part, we may not be dealing with that, but I want to make sure that we understand that we still have those transformations and they still apply to these functions. For example number 2, our job will be to graph f of x, where f of x is equal to a negative, that's going to be our multiplier, and then 2 to the x. So remember, we know what 2 to the x looks like. That's our parent function that looks like this. And this negative is going to be a vertical reflection. That means it's going to make it go over the x-axis. So instead of going up this way, it's going to be coming down this way. And we can see that with our values here. So if I plug in 0, I'm going to have negative 2 to the 0 power. Remember, the 0 power is only affecting the 2, so that's how I get a negative 1, because 2 to the 0 power is 1. When x is equal to 1, I have negative and then 2 to the 1. 2 to the 1 is 2, and I still have the negative on the outside. That's how I'm getting that negative 2. So we can always see it with our points. So what we did know is that normally we would have 0, 1, but because of that negative multiplier, instead of going 0 up 1, we're going to go 0 down 1 because of that multiplier of negative 1. Normally we would go over 1b. That's another point that we know exists. 1b would be 1 and then up 2, but because of that negative multiplier, I'm going to go down 2. And then we can continue forward, right? We can do 2, we can plug that in. 2 squared is 4, but the negative multiplier causes it to go down 4. So I'm going to go from here 1, 2, and then down 4. 1, 2, 3, 4. And we can see those points here. Because we know what it's going to look like, we can see how this is going to continuously go down this way, and we can see how this is going to get towards our horizontal asymptote. The horizontal asymptote did not change because we didn't have any movement of my graph going up or down. Let's go to part B, where we're being asked to graph the function of h of x, where h of x is equal to 2 to the exponent of x minus 1 plus 3. So we can see that in parentheses we have our x minus 1, so it's going to cause our graph to shift over to the right one. The plus 3 will cause my graph to shift up 3. We can see those right here in my dashed red lines where I moved up 3 units and I moved to the right 1 unit, creating my new origin at this point. We know that from our parent function that if we have a parent function, the point 0, 1 will be in our graph. So I'm going to do that by coming from our new origin, go up 0, 1. That's going to be this point right here in black. The other point that we know from our parent function is the point 1, comma b. So that means from my red origin, my new origin, I'm going to go over 1 and then up 2. That's where we get this point right here. Now we can see that it still doesn't have a multiplier in the front, doesn't have a reflector, so we can continue by plugging in some more points if we want to. We can always go plug in the x is equal to 0 and go find the y-intercept? So let's do that so that you can see where I got this number from. So if x is equal to 0, we're going to have 2 to the 0 minus 1 and then plus the 3. And then you can see that my work right here. So we know that this becomes 2 to the negative 1 plus 3. And 2 to the negative 1 means it's going to create the reciprocal, which is 1 over 2 plus 3. And that's how we're getting our 3.5. So we have another point by going to the fixed original origin over here. We'll go to 0 and then up 1, 2, 3.5. And that's where I'm getting this blue dot here. We can graph other points. We know what happens when x is equal to 1. We get 4. We know what happens when x is equal to 2. We got 5. So let's see what happens when x is equal to 3. So let's do that. When x is equal to 3, I'm plugging in 3 for x. So I'm going to get 2 to the 3 minus 1. That's going to be 2 squared. Plus 3, that's going to be 4 plus 3, which is equal to 7. So I claim there's another point at 3, 7, and that's where we have this point here. So we can now connect our dots. We know it's going to be a growth because our base is greater than 1, so it's going to go upward. And we know our new horizontal asymptote is at that dashed line at y is equal to 3. And that concludes our graph and this video.